Recall, Gauss's law says that phi net is equal to E dotted with dA, okay, is equal to Q enclosed divided by epsilon, epsilon naught for vacuum. Okay, so this is what Gauss's law says. Now remember, there are three things here, three equations. There is this equation here, okay, and then there is this equation here, and of course then there is this equation here, phi net is equal to Q enclosed divided by epsilon naught. So there are three equations that you can use from Gauss's law. Now the question is, of course, we've done this, we know how to use them, we've taken several examples on what when to use what, especially if you're calculating the net electrostatic flux, the net electrostatic flux. Okay, so now what you need to know for the final is how to calculate, for example, E dA is equal to Q enclosed divided by epsilon. Okay, remember these two are vectors, okay, and it's a dot product, not cross product, because later on we're going to come to the cross product. Okay, so now the thing here is that what does this say? And you may not, as I said, you may not need to calculate explicitly, but you need to understand what does this mean here. dA here is the one that is the most important thing. dA is simply the area, the Gaussian surface area. And we only took actually two areas only that you need to worry about: the spherical, you know, if you're doing a sphere, or a cylinder if you're doing either a line or a sheet. Okay, and the difference between these two, here you have to calculate the area or the surface area only once because it's symmetric, right? Here you have three surface areas: this surface area, and the curved surface area. And each one of them, this is dA and n hat, right? And this is dA and n hat is this way, and dA and n hat is this way, and dA n hat this way. Okay, so you have to be sure if it is a line or if it is or a sheet. You just have to understand the concept behind what is dA and when is it perpendicular to the field. For example, if it is a line, then these two guys will cancel and these two will survive. If it is a sheet, then this guy will survive, this guy will survive, and these two will cancel. Okay, so make sure you understand when the dA cancels and when it survives, and it's simply because of n hat, and n hat which is always perpendicular to the surface. Okay. Similarly, for the calculating the potential, for a continuous point charge, 4 pi epsilon, and then dq over r, and there you don't have an r hat or you don't have anything. That's something you need just to review and make sure you understand. Maybe you may not be asked to do or calculate something like that, but at least you should be aware of what that is. And that's really the first part, because after that, the topic after that is simply capacitance or capacitors in general. And capacitors, the only thing you need to understand, actually not the only thing, but there are a number of things that, so here we have capacitors, okay, capacitors or capacitance. Yeah. So we took the parallel plate capacitor, we took the cylindrical capacitor, and we took the spherical capacitor, which is something like this. Okay, so make sure you understand. Oh, sorry, the spherical capacitor is something like this. Okay, so this is and this is the one plate is this one, and the other plate is this one. So the one thing that you should be aware of and you should know is that what is the capacitance for each capacitor depends on. Okay, so you go review each capacitance C. For example, here C is epsilon A over D, if I recall correctly, right? The capacitance is simply epsilon A divided by D. Let me just very quickly make sure that, but these things will be given, epsilon A over D, that's right. Okay, so that's for the parallel plate capacitor. You have to understand what this is, the capacitance for this guy is, what the capacitance for this guy is. Okay, And as I talked about that in class, the dimensions are the most important thing. The dimensions meaning the width and the height and the area in between and so forth. Okay, so the most important one is this guy, the parallel plate capacitor. You have to understand first of all the definition of the capacitance, and then this is where the project becomes very important. How do you find the charge on the capacitor? How do you find the voltage difference in the capacitor? And most importantly, the energy. What is the energy in a capacitor, which is from the, remember we had a QV, right? This is QV, something like this. The area under the curve gives you the energy, and the slope of the line, or the slope of this line, gives you the capacitance. So that's the energy stored in the capacitor. Okay, so that's you have to make sure to understand what happens when you insert a dielectric. If you insert a dielectric here, then C is increased by this, okay, by the kappa, by the constant kappa. And remember, kappa is greater than 1, and the electric field is reduced by this amount, and you have to work out the other thing, or the other values, or the values for the other terminology, the other so the example, the energy, the electric field, the capacitance, and all of these things. Now remember, also C, if C changes, and V and Q must also be affected by introducing a dielectric, because the electric field is also affected. Now the other thing that you need to understand, or at least you need to quickly review, is the combination of capacitors. So you have the parallel and the series combinations. So you have to make sure you, for the parallel, they are C1 plus C2 plus C3, that's for parallel, and for series capacitors, 1 over C equivalent is equal to 1 over C1 plus 1 over C2 plus that. You have to be careful with that, and make sure that if there is a dielectric inserted, then the effect of inserting a dielectric is increasing the capacitance of a capacitor. Okay, so that's this basically sums up, or this is all you need to understand for the first part, which we covered in the midterm. And as I said, I mean, this will only amount to something like, maybe 20 to 25% of the final. Now to the fun part. Okay, so the second part, it starts with the definition of the current. So that's the first thing that we started with, the definition of the current, I delta Q over delta T. Okay, and then also I was defined as NQ, or J, let me just say, NQV drift. Okay, that was and then we had something called the resistivity, and something which is defined as the resistance multiplied by, let me just very quickly, the J is, of course I forgot to say, the J is equal to I